All right, welcome. Excuse me. Welcome back, students. In this video, we're going to cover Module 8, Topic 5. This is triangle proportionality. We're kind of building toward the end of Module 8 here. We're still in the packet. This is one of the last two topics. We're on page 13. So let's see. Warm up again. Page 13. We'll just go ahead and get into it. Start with number 1. So find the unknown length or angle measure in each pair of similar polygons. So they tell us these are similar. So we know the angles are going to be congruent and the sides are going to be in proportion. So we'll start over here. So we got a 90-degree angle both here and here. They want to know what x is, and then we have these two angles, so x would be the same for both. Now, 4 sides, 4 angles. We know this is 360 degrees, and we're going to subtract, let me just do this, so 360, we're going to subtract 115 and 82. See, those are the other two lengths, and 90, excuse me. So we're going to subtract the 3 angles from the total, and that should give us x. So let me get my calculator. So we have 360 minus 115 minus 82 minus 90. You subtract all 3 of those out, and you get 73. So x equals 73. Okay, number 2. So we got x here. We're dealing with sides this time, so we're in proportion. We're going to cross multiply. X and 8 are going to go together. And then since I started here, so 21 and 12. X times 12 is 12x. 21 times 8 is going to be it's going to be 168. Divide both sides by 12. And x is going to be, that's 120 and 48, that'd be 14. So x equals 14. All right, number 3. So our side over here is z. 45 goes with that. So we'll just say z over 45. And we have 20 here and 36. So 20 and 36. Cross multiply. All right, so z and 36 equals 36z. And then 20 times 45 is 900. Divide both sides by 36. And z is going to equal 25. So easy enough. All right, flipping up the page here. Again, still page 13, toward the end of the Module 8 packet. Triangle proportionality theorems. Theorem 8.6, triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides the sides into segments of proportional lengths. So what they're saying is, so this guy here, let's see, if a line is parallel, so this would be parallel to this. Then it divides the other 2 sides into segments of proportional lengths. So those would be in proportion to one another. Theorem 8.7, converse of triangle proportionality theorem. So we talked about the sides, we flip it. So we talked about it one way, now we're going to talk about the other. So this says that if a line is parallel to one side of the triangle, this one says if a line intersects 2 sides of a triangle and separates the sides into proportional corresponding lengths, so here, 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 then the line is parallel. So you flip it one way or the other. Either way, lines parallel are going to make these guys into proportion. We're going to practice that below on number 1. Use triangle proportions to find the length of a side. So in triangle BCD, PQ and L and CD are parallel. If QD, that's this guy, is 14.5, and BP, that's right here, is 9. PC, that's down here, is 15. Find BQ. We're going to call it X. And we're just going to go, so it'll be BP to PC, BQ to QD. So BP was 9. PC was 15. BQ is X, and QD is 14.5. So we're going to cross multiply. 15 times X is 15X. 9 times 14.5 is 130.5. X equals 8.7. So this one's 9, this one's 15, this is 8.7, this is 14.5, and those are in the same proportion. And that's why we were able to solve for X. Excuse me. Let me just so you guys see that a little better. All right, number 2. In triangle FGH. FGH. Weird. Sorry, my Walmart delivery is here and it just popped up on my TV screen. That is really cool. Anyway, all right, so in this triangle, FH is parallel to BC. BC, FH. If GB, so here's 14.4, BF, so that's down here, is 4.8. Can't see the point very well. GH, the whole thing, is 21. Find GC and CH, GC and CH. So we have 21, and they want us to, we're going to use the whole length to find one or the other, and then we'll just subtract it. So what we're going to do is we're going to put our little side here, 4.8, over the whole. It's going to be 4.8 plus 14.4. And then the other side, we're going to try to start with CH. We're going to call CH X. So CH is on top, X. And then the whole thing is 21 minus X, because this is the whole thing, and that's X. So whole minus the piece, 21 minus X. Hopefully that makes sense to you guys. No, actually, wrong. We had the whole thing here. We want the whole thing here. I'm thinking ahead. So 4.8 and 14.4, that is 19.2 is what this is. All right, so we'll cross multiply. 19.2 times X is 19.2 X. And then 21 times 4.8 is 100.8. Wait a minute. Oh, I'm trying to put it over. Sorry. All right, let me just check my math here. So 4.8 plus 14.4. All right, that was 19.2. We're right there. And 21 times 4.8 is 100.8. Okay, just making sure. Oops, 100.8 divided by 19.2. Oops, 100.8. Yeah, okay. So now we're going to divide both sides by 19.2. X is going to equal 5.25. So we made CH X, so CH is 5.25, and then GC is 21 minus 5.25, which is 15.75. And hopefully, and then you add these together, you get 21. Hopefully I didn't lose you guys on that one. If you have any questions, ask me in class or send me a message on Focus. All right, flip over to page 14. All right, top of page 14, moving right along. Use triangle proportions to determine if lines are parallel. All right, so we had the parallel lines and we were finding the sides by proportion. Now we're going to do it the opposite way. Which essentially means if we're able to solve for X or solve for our variable, then we know that we're right. So let's see, number 3. All right, so WXY, so YL is 5. LX, so up here is 20. JX, so JX is 4 times as long as WJ. All right, so if this guy is 4 times this, we'll make this x and we'll make this 4x because that's 4 times that, right? Okay. And then it says JL. Is JL parallel to WY? Explain your reasoning. So let's try to put these in proportion and see. So we're going to go 20. We'll just start here over 5. And then we're going to say 4x over x. Cross multiply. So 20x is 20 times x is 20x. 5 times 4x is 20x. So these two are both equal. So yes, JL is parallel to WY. Because they equaled out. All right, number 4. PQR. So PK is 34. KQ is 20. PJ right here is... wait a minute. Oh, okay. It's 1.7 JR. This is JR. I was like, so this is 1.7 JR. And this guy is just going to be JR. We're going to, instead of making it X, we'll keep it up with that. So we start up here with 34 over 20. 1.7 JR over JR. Wait a minute. What did I do here? Oh, I see what we did. So here, I wasn't supposed to put them equal to each other. We'll just do this. So 1.7 JR over JR. The JRs cancel out. So on this side, it's 1.7. If we divide 34 into 20, 34 divided by 20 equals 1.7. So this is 1.7. This is 1.7. So yes, is asked if JK and QR were parallel. And yes, KJ is parallel to QR. And it's because those two are in the same proportion. Oh, sorry, 1.7. The JR's canceled. Okay, moving down the page. Mid-segments of triangle. So we talked about mid-segments of trapezoids before. Mid-segment of a triangle, so that's a segment that connects the midpoints of the legs. So the middle of here, the middle of here, to the middle of here. Notice it makes a little triangle in the middle. So mid-segment connects the midpoints of the legs of the triangle. Every triangle has 3 mid-segments. Why? Because it has 3 sides. That's 3 of everything. So just keep that in mind. The mid-segments of ABC are RP, PQ, and RQ. One special case of triangle proportionality theorem is the triangle mid-segment theorem. It's down here, so I'm going to kind of mix all this together. So 8.8, the triangle mid-segment theorem says that a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of the other side, of that side. So let's do this. So these are mid-segments. This P here splits AB in half. So those AP and PB are congruent. Now, the other side here, R splits this in half. So AR and RC are congruent. And then finally, Q splits BC in half. So those 3 are congruent. And you kind of notice, so we'll deal with this later with this triangle in the middle. So, but just see how these 2 are congruent, these 2, because those are the midpoints. All right, so let's scoot down here. So talking about the mid-segment theorem. So it says if J and K are midpoints, then F and G, FH and HG respectively, then JK is parallel to FG and JK is half of FG. So let me break that down for you. So this cuts these in half. So these 2 messed up over here. We're going to turn that green because it's these 2. Where did my pen go? Here. So these 2 are parallel. Now it says that JK, so this guy is 1/2 of this one. Just highlight them both so we can. So JK is 1/2 of FG. So that's another one of those rules that we're gonna use and to solve our information here. So let's move down the page to the bottom here. Still on page 14, bottom of the page. Why are we so sideways? Okay. 8.1 corollary 8.1 proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut the transversals proportionally. So we talked before about 2 transversals in 1 line. Now we've got 3 transversals in 2 lines. So our example is AE is parallel. Sorry, my pencils keep moving. So AE is parallel to BF is parallel to CG. Then, so if those 3 are parallel and these cutting these 2 transversals, it says that AB and BC are going to be proportional to these guys. So just like we did above. Okay, so let's flip over page 15. I think 16 starts the next topic, and I'll do in the next video. But page 15. So we'll finish up topic 5 here. All right. Let's see. Corollary 8.2. Congruent parts of parallel lines. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. This kind of goes back to that if you're symmetric and transitive and all that. So let's see. Can't hardly see what it's saying there, but let me get something we can see. All right, so these 3 guys are parallel. Cuts these transversals. These are congruent. So, all right. So if all 3 of these guys are parallel, then AB and BC are congruent. And then on the flip side, EF is congruent to FG. All right. So I'm going to scooch down a little, but I want to leave a little of that so we can kind of see it because we may need that info. All right, number 5 on the left. In the figure, EF and DE are mid-segments of triangle ABC. Find DE. All right, so EF. Let's just go around. So EF splits this one. I see it's already got. We'll just do this. So this splits this. This splits this. And that splits that. Find DE. All right, so DE is right here. Well, we know that, so if these are the mid segments, it still looks a little weird. But DE should be half of AC. We learned that on the previous page. So DE is 1/2 of AC. They tell us that AC is 15. So 1/2, 15 equals 7.5. So DE is 7.5. Easy enough. Number 6 on the other side. So in the figure, FG, GH, and FG are mid-segments of ABC. So we'll just do that again. All right, so all those things are the same. Find the measures of AC, CB, AH, AB, and CG. So let us see. All right, so this seems like it's way complicated. It's not bad. So FH is this mid-segment here. It's half of this guy. So CB, That's one of the ones we got to find. CB is going to be 2 times FH. You know, over here, this was half of this. Well, then the big one is double the little. If the little one is half of the big one is double the little one. So that's how we're going to do that. So CB is 2 times FH, which is 2 times 14. So CB is 28. All right, so if these guys are congruent, if the whole thing is 28, CG is 14, BG is 14. CG is 14, BG is 14. That's that one. Just trying to get them all, make sure we get them all here. So we have this one and these two. What else do we need? Okay, so looking this way, I want to make, I'm out of extra colors tonight. Let's see if this is a black pen. Maybe we can see better. So flipping this way, FH, or FG, is going to be 2 times AB. So AB is, no, it's, yeah, 2 of those make this. So 2 times FG, 2 times 19.5, which is 29. So AB is 29. I'm going to go back to my other pen because this one's terrible. So if this is 29, 19.5, 19.5. Also notice the half, so we really didn't even have to do all that. So this other side, this is 16.5. This is double that. Well, half of double that would be 16.25. 16.25. So we have AB was 29. BG, no, that was over there. What is it? BH, excuse me. BH is 19 and a half. And AH, 19 and a half. I think that's all they asked for. But over here, AF is 16.25. FC is 16.25. And then AC was both of those together, which is 32 and a half. So, sorry, it was off the page. But you see 16.25 for both of those. The whole thing, add those together, makes AC, which is 32 and a half. So all those things are easy enough. I mean, the mid segment is half of the base. The mid segment's half of the base. The mid segment's half of that base. So same thing. We'll talk about this more in class. All right, flipping down to the bottom. Last two of this particular topic, number 7, number 8. Sorry. Okay. All right, number 7. Find the values of x and y. Okay, well, we've talked about this before. We can't solve both of those at the same time. So we got to work with x's, got to work with y's. Simple enough. These guys are parallel. That means these two are congruent. And these two are congruent. So y's go together, x's go together. They're equal, so we put them equal. 2x plus 8 equals 7x minus 12. I like to take the smaller, so 2x it is. The x's cancel out, 8 comes down, 7x minus 2x is 5x, and the negative 12 comes down. Add the 12 to both sides. Add the 12 to both sides. That cancels. 5x comes down. 8 plus 12 is 20. Divide both sides by 5. X equals 4. All right, over here with the y's, same thing. 4y minus 1 is going to be equal to y plus 8. Negative y, or subtract the y from both sides. 4y minus y is 3y. Negative 1 comes down, equals, those cancel out. We got 8. Add 1. Add 1. Cancel. 3y equals 9. Divide both sides by 3. 9 divided by 3 is 3, so y equals 3. Easy enough. Number 8, hopefully you guys have paid attention and won't even need me to do this, but so parallel lines, these guys are going to be congruent. Put x is equal to each other to solve for x, put y is equal to each other to solve for y's. So 12 minus 3y equals 16 minus 5y. So notice here we have the negative y's. So I would go backwards here. I would add the smaller, add the bigger to both sides. So we get a positive number over here. 5's cancel. Negative 3y plus 5y is positive 2y. Notice this changes because that's not a negative. 16 comes down, the 5y's canceled. Subtract 12 from both sides. Those cancel. 2y equals 16 minus 12 is 4. Divide both sides by 2. Y equals 2. This side. 1/4 x plus 6 equals 2x minus 29. Let's subtract the quarter x from both sides. They cancel. 6 comes down equals 2x minus a quarter x is 1.75 or 1 3/4 x minus 29. So we're going to add the 29 to both sides. Those cancel. We got 1.75x equal to 35. Divide 1.75 by both sides. So 135 divided by 1.75, give me just a second, is 20. So on this side, x equals 20. All right, that's it for this topic. Topic 6 is pretty short. I was going to combine them, but we'll just do them separate. If you guys got something out of this, if you have any questions, let me know. Until next time, have a great evening.